Hello everyone, in this video we will discuss one of the analytical methods in analytical chemistry, namely potentiometry. Potentiometry is an electrochemical method that is very important and widely used in the fields of education, research, and industry. This method is well known for its accuracy, simple instrumentation, and its ability to analyze various types of ions in solution. Potentiometry is an electrochemical analytical method based on the measurement of the electrical potential difference between two electrodes, namely the indicator electrode and the reference electrode, without the flow of a significant electric current. The measured potential difference is directly related to the concentration or activity of a specific ion in the solution. Therefore, potentiometry can be used to determine ion concentrations quantitatively. One of the most common applications of potentiometry is pH measurement using a pH electrode. A potentiometric instrument consists of several main components. The first is the indicator electrode, which responds to change in the concentration or activity of the ion being analyzed. The second is the reference electrode, which has a stable and constant potential and serves as a comparison. The third component is a voltmeter, which measures the potential difference between the indicator electrode and the reference electrode and displays it in volt. The working principle of potentiometry is based on the Nernst equation, which explains the relationship between electrode potential and ion concentration. When the indicator electrode is placed in the analyzed solution, it develops a potential that reflects the concentration of the target ion, while the reference electrode maintains a stable, constant potential. The potential difference between these two electrodes is measured and used to quantitatively determine the ion concentration in the solution.
Hi everyone, I'm Dinar Rahmawati with student number 078. So the next, what are the function and applications of potentiometry? So first, we're gonna talk about the function of potentiometric. Potentiometric instruments have several main functions. They are used to measure the concentration of specific ions, determine the pH of solution accurately, detect changes in potential during chemical reactions, and determine the equivalence point in titration. Potentiometry can measure ions such as hydrogen, sodium, potassium, and others. This measurement uses ion-selective electrodes, and the results follow the Nernst equation, making it suitable for quantitative analysis. Potentiometry is commonly used as a pH meter. It measures the acidity or basicity of a solution quickly and accurately. This method is easy to use and doesn't damage the sample. You know guys, in potentiometric titration, the equivalent point is determined without using color indicators. This method is very useful for colored or turbid solution and gives more objective result than conventional titration. It can be applied in acid-base, redox, and precipitation titration. In environmental analysis, potentiometry is used to measure water quality, including pH and dissolved ions. It also helps monitor water pollution and wastewater, especially in aquatic environments. And in industry, potentiometry is used for quality control. For example, in pharmaceuticals, food and beverages, and chemical industries to monitor pH, ion content, and production processes. In education and research, potentiometry is commonly used in analytical chemistry laboratories. It helps study ionic equilibrium, electrochemical reactions, and ion-selective sensors.
Okay, in this slide, there are 5 main stages in potentiometric procedure. The stages include instrument and sample preparation, initial pH measurement, titration setup, titrant addition, and determination of ion concentration. This step describes the general workflow of potentiometric analysis. So, next I will show a short video that demonstrates the potentiometric instrument procedure. So, in this video shows how the potentiometric titration is performed using a pH meter, include the electrode placement, titration addition, and data recording. Okay, based on the video shown, the potentiometric procedure can be explained as follows. First, step 1, instrument preparation. First, the potentiometer or pH meter, electrode, burette, and magnetic stirrer are prepared. The sample solution is also prepared until homogeneous solution is obtained. For step 2, initial pH measurement. The next pH electrode is immersed into sample solution to measure and record the initial pH value. For step 3, titration setup. Then the titration solution is placed in burette while the electrode remains immersed in the sample during the titration. For step 4, titration addition. After that, the titration is gradually as the solution is continuously stirred to ensure uniforming mixing. For step 5, determination of the concentration. Finally, the pH value is recorded after each eddition of titration until the equivalent point is reached, and the data is used to determination of concentration the sample.
Okay, now let's talk about a case study. This study is about a new way to measure organic carbon in soil. It uses a special CO2 electron and is better than the old titration method. The old way uses titration. The problem is you have to watch for a color change to see when the reaction is done. This can be unclear sometimes, give you wrong result, especially with complex soil. The new method is different. It uses electrodes to sense CO2 gas. First, the organic carbon in the soil is turned into CO gas. Then the electrode is measuring this gas. The reading you get is directly related to the amount of carbon. And here, how it's done. We take 2 grams of dry soil and we add 25 ml of sulfuric acid. Then we add potassium permanganate to turn the carbon into CO2. The electrode measured to CO2, and we compare this reading to a calibration curve to the final number. This test was done on 4 soil types, as let's salt, methyl, alphisol, and adisol, to make sure it works from different kinds of soil. The new method gave lower numbers than the old titration method. Why? Because the old titration also react with other minerals in the soil, not just organic carbon. This means the old method can overestimate the carbon amount, so the new potentiometry method is more accurate. It doesn't rely on watching color, it gives a direct electrical reading, and this makes it better and more reliable choice, especially for soil with a lot of different components.
Potentiometry is widely used because it allows fast, accurate, and real-time measurements of pH and specific ions. Potentiometry is very important in industrial applications because it provides rapid analysis without destroying the sample. So the first is in food and beverage industry. In the food and beverage industry, potentiometry is commonly used to measure pH in products such as milk, yogurt, soft drink, and fermented foods. Here, the pH measurement is important because it affects test product stability and food safety. And the next is in pharmaceutical industry. In here, potentiometry plays an important role in controlling the pH of liquid medicines, injections, and syrups. Lastly, in environmental applications, potentiometry is used to monitor the pH of industrial wastewater. It is also used to detect harmful ions such as nitrates and heavy metals. This helps industry ensure that their wastewater meets environmental quality standards before being discharged. That's it from us about the potentiometry. Here we can conclude that the potentiometry is an important method for accurately measuring electrode potential and ion concentration in solutions. Thank you so much for your attention. See you on the next occasion. Bye!